Hey guys, what is up? This is Kazi from cleverprogrammer.com, where we learn to code smarter. Today, we're going to be talking about Coursera Week 2, Assignment 1, Part 2, where we will learn to complete the complete function. Okay, so before we get started, the most important thing to understand is the problem itself. Okay, so first let's make sure we understand what it's saying. When I was going through this course a while ago, it was confusing to me what the problems were saying most of the times. And because I took less time to think of what the problem was actually saying, I ended up spending more time coding incorrectly. So I will try to break down what the problem means. We have here part 2, write a function that reads a directory full of files. I'm sure you guys have read it, so I'm not going to read it word for word. But essentially what we're trying to do is we're trying to write a function. It'll read a directory, okay? So we have like a bucket full of files. Now there are a lot of files in there. Specifically, there are 332 files. Okay, if you've downloaded the folder called SpecData, you have 332 files in there. You need to run through each of them. So let's look at what it looks like. For example, I have week 2 here, right? And I have my SpecData, and the files that I downloaded look like this. Each file has, it's basically comma separated files, okay? If I open it up in Excel, it looks like nice tables. In reality, it's all separated by commas, okay? Just if I could show you what it looks like. This is what it looks like, you see? 2003, 11, comma, NA, comma, NA, comma, 1. And that gets rendered as a nice little table right here. And if I open it up in Excel, it would look the same way. I just don't want to open it in Excel because Excel will open it slower. So here's what you have, right? Now what they want you to do is count the number of complete cases. You have 332 of these files, okay? All with different amounts of data. All of them talking about sulfate and nitrate, right? Or at least most of them. Let's go down. Yep, I think all of them talk about sulfate and nitrate. What is a complete case, first of all? A complete case is a case where all of the data in that given row is completed, okay? For example, the first row, you have NA, which means non, I forgot what the A stands for, but essentially, you don't have any data there. So you have this as incomplete, this as incomplete. So this row is not a complete case. Now let's come to the second row. Is this row a complete case? Nope. Let's come down to the third row. Is this one a complete case? Nope. Let's keep going down. Here we see our first complete case. We have 5.99, we got 0.428, and we have for ID 1. Why is ID 1? Probably because it's the first file, so they just decided to make it ID 1. Okay, so we got 5.99, 0.428. Again, we have another complete case right over here, 4.68, 1.04, right? Those are all the complete cases. Now, if we were to go by hand and count all of these complete cases, well, what would be the answer? What would we get? How many complete cases are there? And how we need to show the answer is also important. So here, I should actually keep that open because that looks good. Now, if I go an example output of what this is supposed to give us. So if we write our function called complete, and if we run it, and we give it like, okay, run on this directory, SpecData, and I want you to run for just the first file, okay? I only want you to run one time and for the first file. It should run through, it should tell you that the file ID was 1, and it should also tell you that the number of complete cases found were 117. This column is confusing, it's called knobs. It should really just be called complete cases. I think they did that maybe to throw you off, unless knobs has some kind of definition that I'm unaware of. So it should give you a column with ID and a column with column saying knobs, and knobs should be the number of complete cases for that given file. So for example, for the second file, you have 1041 complete cases. For the fourth file, you have 474 complete cases. Okay, so hopefully we understand what the problem is asking us. Notice also how they passed it, right? They said look for the second file, then look for the fourth file, then look for the eighth file, 10 and 12. That's why you got a search for 2, 4, 8, 10, and 12. Now, we don't know how this function is working, but we do see how this function is supposed to work, okay? So now we're gonna worry about the actual implementation details and see how we implement it. So let's go over to our console in R. Okay, so first thing we wanna do is we want to get, let's bring this right over here. First thing we want to do is we want to get all of these files. We want to have them somewhere so then we can run through them. Okay, so first thing you need to do is check where you are currently. I bet a lot of people, if you're new to programming especially, you're probably in some wrong directory and you're just like racking your brain. What the heck do I do? But you're most likely in the wrong directory and unable to pull the file. So make sure that you're in the right directory. So for example, my getwd told me where I currently am. Okay, so let's just follow this path. So it says I'm in users, which is like all the way back here. All right, so at the bottom left you see users, right? And now I'm in Macintosh HD users. Then it says go to Rafe, so I'm gonna click on Rafe. Then it says go to Dropbox, so I'm gonna go to Dropbox, wherever it is. Where are you, Dropbox? Here it is. Now I'm gonna go down to where it says GitHub, and then it says Coursera. So I'm gonna find where Coursera is. Found it. It says R Programming. Found that, and that's where we are. But we should go even further. We should go in week 2, so we're actually right in the same directory as this folder called SpecData. So what I'm gonna do here is I'm gonna say set WD, and it takes a directory as an argument. Since I'm already all the way here, I can just give it a relative directory, okay? So the difference between an absolute path and a relative path is that if I'm already here, I can just say like SpecData instead of having to say /users, okay? Instead of having to say /users, /Rafe, /Dropbox, / all the way up to R Programming and then SpecData, I can just say SpecData right now because I'm already there. It's almost like saying if I'm here and something's to my right, I can just say it to my right. But if I was in another country, I can't just say to my right. I would have to give the absolute path, right? I have to get the longitude and the latitude, or like specific Google Map type of directions. The directories in our computers work very similar way because they're made by humans. The programming is done by humans. That's what I mean. Okay, so I'm gonna set my directory to SpecData. Actually, it's not giving me a match, so hopefully, oh, sorry, week 2, right? Hit tab, because then it'll give you a match. So I'm gonna set my directory to that. Now at the top here in the console, you see it says Dropbox /GitHub /Coursera /R Programming /week 2. The squiggly here just means /user /Rafe. So this part here is my home. So that's actually defined by that little squiggly there, at least in Mac and Mac OS. Okay, so if I did get WD now, I should see that I'm in week 2. That's good. Now I can do ls to see what's around me. Okay, it's kind of like I'm looking around. So if I look around, I have all these things like file list plus functions. So let me just check if that matches what I found in my Finder, or in your Windows, it's like your Windows Explorer or whatever. Is there file list near me somewhere, or any of these things? A data. None of that is there, but oh, ls is mostly telling, is it telling me my local variables or something? Because it's not showing me anything in here. Okay, so ls is, in this case, I think showing me something like my variables or something. It's not necessarily showing me everything that's in here, which is what ls does on your terminal. But regardless of that, we know that we're in the right place, right? We have week data, we have week 2, and we have week 2 right here. So we know we're in the correct place. And then if we go into SpecData, we'll go to all these files. So now we want to create a list of all those files. Okay, so that way we have access to them, and then we can like maybe loop through it or something. And first of all, let's take one file and see what we need to do to get all the complete cases. Cool. So let's take, I can do file list, or I can do like, let's say read.csv, and I can give it a file name. So I can say SpecData, and I can give it this file 001.csv. So I'm saying, hey, I know I'm in week 2, which is like this whole directory right here, right, with all these things. And then I'm saying, go to SpecData, and then grab this file and read it. And it's a CSV, right? You see that? So I said 001.csv. So let's see what happens when I read this file. It basically reads the entire file. However, I didn't save it to a variable, so it's kind of lost. So let's just say, I hate the variable x. I'll never ever use it. I hate those one-letter variables. I try to avoid them. Almost all programmers try to avoid them because they just create a very convoluted world. So avoid one-letter variables at all costs. Name them something, even if it slows you down. Get in the habit of naming meaningful variable names. It'll save you in the long run. Okay, let me do data and let me see what it gives me. Essentially, you can see here that it gave me that file, right? It gave me that file. So if I look at the last record, 2006 1231, right? Let's scroll all the way down. 2006 1231, we have NA and A, and then I have 1 at the end there, right there, right? So we are actually able to read the actual file. That's great. Now, how do we get the number of cases that are all complete? Well, so we know that data, right, is that file. So let's do this thing called complete.cases on data, and let's run it. Okay. So here, what it gives us is a Boolean vector. Boolean vector just means something, it's like a list or a vector, and at each element it's containing false and true. Each place is containing a true. That's where the actual value, that's where it's a complete case. So for example, in this row here, right, I think this is 289. So this is 290. In row 291, if you look, you should have a row where all of the cases are complete. That's what the complete.cases function does. It looks for each row that's complete. So everywhere in our table, right, of 14, that file has 1,441 records. So everywhere it saw that it was a complete case, it put a true, and everywhere it saw that it wasn't a complete case, it put a false. Now, if you know a little bit more, you know that true is really 1, right? It's like a secret 1, and false is a 0. Using that knowledge, we can simply sum up this vector, right? If you had some vector and you did sum of some vector like 5, 4, you would get its sum. Just like that, this whole thing, even though it looks huge and complicated, it's the same vector as C5 comma 4. So if you call a sum on it, it'll sum up all of the ones. Once it sums up all of the ones, you essentially have your complete cases. So let's do call sum on this, right? Because this whole thing, once it gets evaluated, it turns into that giant vector with 1,441 values. So I'm just going to call sum on that once it gets evaluated to that, and you get 117. And if we go back and you look, when they ran it on their first file, they indeed got back 117 completely observed cases. Okay, so we know we're on the right path. We know our logic is correct. Now there's some more implementation details that we have to worry about. We have to make it so it loops through and does all those files maybe at the same time, right? How can we do that? Whenever you think of something that requires repetition, you should think of loops. They're very helpful. The idea is the same. We need this thing to happen over and over again. Loops. More specifically, in our case, for loops is what we're going to be looking for. So we want to be able to go through each of these files. Now, for us to be able to go through each of these files, we need to have each of these files on hand. So let's create a variable called like file list and store all these files in there. So I'm going to show you, first of all, there's this method called list.files, and it essentially lists all the files in a given directory. So how it works is it takes a path, and then it takes a right, it does full names, and it also takes a pattern. Okay, so let's break it down one step at a time. So first of all, let's keep pattern in there, and let's put path in there. Okay, so I'm going to show you guys what it does. Okay, now again, I'm in week 2, so I need to go into SpecData, and then I need to pull out something. So I'm going to say SpecData. That's the file I want you to go to. That's the folder I want you to go to. And in that folder, I want you to list all of the files. Okay, just to check again what I'm talking about, I'm telling it, hey, I want you to go into this folder SpecData and give me all of the files. Put them in a vector for me. Cool. And I'm going to hit run. Okay, so if I do file list and I do this, let's call the function length on file list. You can see that the length is 332, which matches the length of this, right? There are 332 files in here. So great, we got all of the files. Now, what's the point of pattern? Why should we use pattern? Well, it's a good idea to use pattern because with pattern, you specify what kind of files you want. So just in case you had some other files, like, I don't know, .mov file in here, like a movie file, an HTML file, and a bunch of other crap, it would ignore all of the other files and simply look for all the files that have CSV appended to them. So that's why we want to use pattern. Like in our case here and here, it doesn't make a difference. We'll still get the same file list, but you want to use it just to be more correct, and especially if you want to run it on something other than this, project that we're doing. Okay, so that's all great, but we still can't access the complete file because we don't have the complete path. So it's great that we have the entire file name, but it would be better if we had the entire path, like the absolute path to each of these files. That way we can refer to them from any directory and it would work all the time. Okay? Like we can be anywhere and refer to them. What I mean is, right now, to work with them, our directory would have to be in this folder called SpecData, and then it would work because it'll be like, oh yeah, I know where 183 is and I know where 184 and 185 is. But like, let's say you were in our programming folder, so like this folder here, and you said look for 310, it'd be like, there is no 310. I don't see it anywhere. So, you know, or if you were even in week 2 and not in SpecData and you said look for 310, it would have no idea where it is. You would have to be in SpecData. So let's try to get the full name of the full path name. So let's do full.names is equal to true. It's false by default. Oh yeah, true is all caps, right? And now let's do file list. And you can see their full path. So in this case, relative to wherever you were, it gave you the full path to them, how to get to them from where you are. So that's really helpful, because if your program is running, wherever it is, it'll give you the full path from that location all the way. It understood that we're currently in the folder week 2. So the path that we need, the full path, is SpecData and that. Okay, cool. So it doesn't give you absolute path, but it gives you like a relative full path. Okay, so this is really good news for us. We have gotten all of the data that we need, right? Now, like, let's say that I wanted to read one of these files. I can do read.csv, and I can do file list of, let's break it down. File list of 1 will give me the first file. File list of 2 would give me the second file. So I can just do read.csv file list of, like, let's say 1, and it reads that file. And like, on that, I can say give me the number of complete cases, and then on that I can call the function sum. Okay, so here I'm calling read.csv on the first file, which is SpecData/001.csv, right? I call read.csv on that, so now it read all of that. Once it reads all of that, I want to call the complete cases function, so it creates that Boolean vector with true and false. And once it does all that, I'd say call the function sum on that Boolean vector, and then it sums up all of the trues and gives me back that there were 117 cases which were complete, 117 rows which were complete. Okay, nice, right? That's really cool. We were able to do that. Now, this part remains the same. What's the only thing that changes every single time? It's just that, right? That's the thing that needs to change every single time. The rest of the code remains the same. So we should replace that with a variable. The very definition of variable is something that changes, right? So, you know, the word varies. So in this case, 1 should not be a constant and hard-coded. You see how I broke this part down into its little pieces, right? It's really a bunch of problems combined together. And the main problem happens when you try to tackle all of it at once, right? The biggest problem I see people doing is to start to code here in this part right away. Don't start writing a script right away when you have no idea what's going on. Languages like R and Python are absolutely amazing for this very reason, because they have something called an interactive terminal, so you get to have immediate feedback for everything that you do. No matter how stupid it is, you get to try it out here and check it and see if it works. So you experiment your ideas here and you try things here, and once they work, then you go and try to write a script that summarizes your thought process in a succinct manner. That's what a script is, all right? So don't be trying to write a script right away. Do this here, solve the problem in the terminal for at least 1 or 2 cases, and then you can summarize that right in the script. Anyways, let's keep going. So you saw how I created file list, right? Created that vector essentially, then accessed the first guy, which is the path. So this unwinded, right? It unwound as a path. So, you know, this value got put in for that value right there. Then read.csv got called on that, so on and so forth. So what we want to do is we want to essentially run for all of these, right? We want to be able to run for every single one of these guys. Okay, how do we do that? That's what we need to figure out, okay? Now, another thing that could change on us is the number of files they want. So they give us a variable like ID, which a user can put in, right? Whatever they want that thing to be. So they can ask for 10 files or 3 files or only the second and the fourth and the seventh file. So we need a function that has like a way to take care of that as well. So let's talk about that. Okay, so let's start. I think we're at a good point to start coding this up because we have some idea on how to start summing these up. Now, another thing is that as we sum these up, we need to store it somewhere, right? So let's just do one example in the terminal, and then we'll go and do more examples. We'll do more of the coding up at the top. So I'm gonna create like a thing called knobs and create a numeric vector. So I'm specifying, hey, you're a vector and you can only have numbers in yourself. Okay, so that's really what it is, just a numeric vector. All right, so we have knobs. Now every single time we get a value, we need to remember it. Yeah, so every single time we get the number of complete cases, because we need to remember it, we need to store it in a list. Lists are really good for that. So because otherwise you're going to forget. You're going to get 117, then the next time you're going to run on the second file, you're going to get 1,000 cases completed maybe, but you forgot about the 117. And by the time you get to the 332nd file, you've forgotten about the previous 331 files and only will spit out the result of the 332nd file. That's not what you want to do. So how we can do this is up there we wrote this line, right? That essentially gives you the number of observed cases in the first file. Well, let's do this. Let's say knobs is what it in the new knobs is going to be a vector of what knobs previously was, which is an empty vector, and we're gonna concatenate that with this line up here, which evaluates to 117, right? We want to actually do this, 117. But that just hard codes it for only one of the values. That's not what we want. So let's go redefine knobs. Now we make it a little bit more abstract so it works for all cases, right? So let's go to where we're saying this 117 part. This part really rolls, right? This part unwinds into 117. And now if I show you what knobs is, whoops, you get 117. Now we need to do the same thing for the second file, right? And knobs is now 1041. What happened? This is essentially just saying again, knobs, what knobs previously was, which was 117 after this line that we did here, and then we just concatenate the next complete case sum of the second file. And if we just run this again and replace this with the 3, then run it again, replace it with the 4, run it again, replace it with the 5, 6, 7, 8, and if we do that maybe 332 times, you essentially get back something that looks like that. 117, 1041, 243. These are the number of completely observed cases in file 1, which is 117, file 2, which is 1041, file 3, which is 243, so on and so forth. Great. Now we have a very repetitive process that we've broken this down into. What does that sound like? Sounds like a for loop. Let's do it. So let's define a function complete, right, which is dependent on what path you give it. Let's say that the path initially is, we can say it's empty, right? We can just say that the initial path is empty. Optional argument, right? Optional argument. Then for the second one, what do we need, right, for this function? So actually a better name for this would be directory, because we're depending on what directory the user gives us, right? So we can just remove that. So first of all, we need a directory from the other person. Unexpected end of argument. Well, it should be like this. Okay. Once they give us their directory, so for example, we would expect them to put something like SpecData, right, as their first argument, or week2 / SpecData, or R Programming / week2 / SpecData, something like that. So that's what we're expecting in directory. Now, what are we expecting in here? Well, here we're expecting an ID, right? Which in this case, we can make it, right? So if they don't give us anything, we're gonna assume to just run through every single file. So these are your keyword arguments, which is if somebody doesn't give you some argument for this, then by default, it's gonna make ID equal to a vector of 1 to 332, right? ID is equal to 1 to 332. If I do ID, you get back, boom, right? That whole thing there that you see. Okay, great. So we have those things down. That's good. Now let's create our file list that we created initially. We're going to use that function list.files. It's dependent on the path. Path is going to be the directory the user passes it. Directory is, we're assuming, again, it's a string. Now, what else do we need? We need a pattern, right? A pattern. So we're telling it, look only for CSV files in here, so nothing else. And again, we want to make our functions as less error prone as possible. We don't want the user to be really annoyed and our function make mistakes. We want it to be like the user tries to run the function and it just works magically, okay? And then last thing is we want the full names to be true. Okay, great. So now that creates our list of files. After we're done creating our list of files, we need to instantiate or initialize our knobs variable to be a numeric vector. All numeric is doing is just saying, hey, you're going to be a vector that only contains numbers. The reason why we're creating a vector is so we don't forget any of the values as we run through the loop. We're storing it in this numeric vector as we go along the files. Now, what I'm going to do is I'm going to write a loop. Remember, we were talking about a loop. So I'm going to say for I in ID, and all it does is it just runs through, right? That's what a loop does. It just runs through every single value in the vector. So for example, if you have 1:332, right? This essentially looks something like, I'm just gonna, create a Python looking vector here. It looks like this, right? So the first time I is gonna be 1, ... just to specify that it goes all the way up to 332. First time I is gonna be 1, then I is gonna be 2, then I is gonna be 3, then I is gonna be 4. Okay, so hopefully that part of the loop is clear. So I'm gonna say for I, and I don't need to make this I can call it literally whatever I want as long as I stay consistent, but that would be a very inconvenient variable name. So we'll stick with I just don't want you to think that I has some kind of magic in it. And yes, I need to close that. Right, this on line 8, the squiggly bracket matches the squiggly bracket on line 1, so that's important. Now, as we go through the loop, that's essentially the I part is just that part where it says 6 right here and 3 right here, right? We just want to increment that every single time. 3, 4, 5, 6, 7, 8. That's our I. It just gets incremented every time, and as you can see in our loop, that's going to be incrementing every single time. So let's create a variable called data and say that we're going to access file list of I, and then we're going to read it. Okay. So here we create our vector of files. Then we read starting from the first file, and we store that data in data. right? And now what we want to do is we want to say knobs what knobs was, concatenated with sum of complete dot cases on that file data. Okay, so this part just does what we talked about right here. That's all that part is doing. Okay, except read.csv part, we just call it data in our more nicer and more readable function. And that's it. We're pretty much done, right? We got that whole thing. And last thing I want to show you is if I do knobs down here, right? We have 1, 2, 3, 4, 5, 6, 7, 8 files. We got 117 complete cases for the first one, 1,041 cases for the second one, 243 cases for the third one, and 474 cases for the fourth one. We have 1, 2, 3, 4, 5, 6, 7, 8 files. So if I do ID is equal to 1:8 and I do data.frame, right, and I do knobs, just give it knobs, it's going to create a data frame with knobs. And if I do data.frame ID comma knobs, you can see that it creates a data frame with the first column being all IDs and the second column being all the complete cases. So it tells you the first file has 117 complete cases, and it tells you the seventh file has 442 complete cases. Ignore the 1, 2, 3, 4, 5, 6, 7, 8 on the left-hand side. That has nothing to do with the ID. It's just a coincidence that the file names begin with 1. But imagine I wanted the files to begin from the fifth one and onwards. Then you had a 5 here going up to some other number, and you would still have a 1 here. So these have nothing to do with what the ID and knobs are. Okay, so essentially by the end of this, we have that vector that contains all of the values that knobs is supposed to contain, all the complete cases, and we have all the IDs which user gives us. So it's really quite simple at this point. We can just simply say data.frame ID comma knobs. Okay, and that should be our function. So are we doing something funky here? Let's see, what is it complaining about? Unexpected that in that. Unexpected. Oh, it was just some silly error here, but no, I read this fine. Another one I would tell you guys to do is always check that box source on save. So then that way you don't have to press Command Enter here and do, for example, you would have to do this button source, or you would have to do whatever. With source on save, if I just save it, it sources it right here, which means that now I can call this function complete and my console knows about it as well. So now I want to call this function and use it because I got it right here. So I'm going to say complete, and it's telling me what arguments it takes because I defined it up at the top. So it tells me it takes directory and a given ID. So I'm going to say take directory SpecData, and then that's all I give it, right? It asks for a directory, not for a specific file name. So I'm going to leave it at that. And then for ID, I'm going to say, hey, I'll give you the ID 1. So I only want you to run for the first one. And boom, look at that. Magic, right? That's beautiful. It gave us what we needed. Now I'm going to say I'll give you 1 and 2. And it made it for 1 and 2. And I'm going to say I'm going to give you 1 and 5. And it gave us 1 and 5. What happens when I give this thing 1 and 5? Well, ID is essentially, right, this part here gets read as a vector, right? How I think of vectors, because I come from Python, is like this, right? So it has two values, 1 comma 5. So we have ID of 1. ID is really 1 comma 5, this list here. This whole thing gets turned into all of the files. So we have all of the files. I, the first time, is 1. So using 1, this gets me the first file from file list. Okay, first file is translates to it translates to read dot sorry, not read.csv, but 001.csv, and also SpecData. That's what it turns into. So data reads that. Then data is essentially that entire table, which is that entire file, SpecData /001.csv, with the nitrate and the sulfate and the ID and the date. Then I call the complete cases function on it, and it tells me how many it gives me a Boolean vector for all of the complete cases. And then I simply call sum on that Boolean vector. So all the trues are essentially ones. It sums them all up, gives me back 117, which is what I get down here. And knobs initially was an empty vector, and so it goes knobs is now an empty vector concatenated with 117. Empty vector concatenated 117. Well, you simply have 117 right after this loop part ends. Then the loop happens again, and now this part that was I is now 5. So it goes down here, it pulls out, it says file list of I. Since I is 5, this part evaluates to read.cs, oh sorry, I keep doing that, SpecData /005.csv. It reads the 5th file from the vector, right? This vector has all of the files, so the 5th element gives you the 5th file, and data is now the entire table, sulfate nitrate, of that 5th file right here. Call complete cases on it, gives us a Boolean vector. Call sum on it, gives us the sum of all of those true values. We concatenate that to what this was. This was essentially 117, right? And so once we concatenate this part, because it evaluates to something like 1041, now essentially knobs becomes 1041. So it keeps going like that. And so here you have 117 and 1041 being knobs, and ID is 1 comma 5. So you have two values of ID and you have two values in knobs. That's a perfect situation for a data frame. And you can simply call a data frame, and since they both have equal number of values, you get a beautiful looking data frame right here. ID 1, ID 2, knobs 117, knobs 1041. Okay, hopefully running through that algorithm broke it down, and you now know exactly how that thing works in painful amount of detail. So I love this, right? It was a lot of hard work, a lot of brain power the first time we went through it. But once it's done, it's just like, I only worry about using it, nothing else. So let's say I only want it up to 220 whatever files. It's gonna take a second to run, and it gives me back this. So now let's go, one good thing to do is test it against their test cases. So let's go do complete SpecData and run it on 117 is what we should get. Let's check. And we indeed match up against theirs. Now let's run their second unit test. You should get back 2 1041 and like 8 192. Let's just check, and we do get 8 192 and all of the other same values. Now let's try creating a list of numbers that goes backwards. So this vector goes from 30 to 25, right? So it's actually 5, but it goes 30, 29, 28, 27, 26, 25 CSV files backwards, and it gives you that data frame. So 27 should have 338 in front of it. 27 does have 338. Let's run their last unit test just to be exhaustive, 3 and 243, and we indeed have 3 and 243 here. Hopefully you guys have a complete understanding of how the complete function now works in this programming assignment in Coursera. This is Kazi. Thank you guys for watching, and I'll see you in the next video.